completing the square. You have learned about completing the square before in Algebra 1, and this is just going to be kind of a reminder on how to do it. And then in class we're going to go into some that are more difficult, that have fractions, and the fractions get a little trickier. So this is just going to be your basics. Okay, so we're going to start out by remembering. Okay, so remember x squared minus 6x plus 9 equals 0. Now, how would you solve that? Okay, so we've done these already. We did these in chapter 6. And we solved these, and we looked at these and we said, oh, well, this is a perfect square, right? The first term is perfect square. Oh, the square root of that is x. The last term is a perfect square. The square root of that is 3. And then we had this little check, just to make sure that it was a perfect trinomial, square trinomial, sorry, perfect square trinomial. We said, okay, if you multiply these together and then multiply by 2, do you get the middle term? And yeah, 3 times x is 3x times 2 is 6x. Yes, I get the middle term. And this sign is what goes right here. And that means it's squared, and that's equal to 0. Perfect square trinomial. Okay, and then if we were going to solve, then we would say, all right, well, x minus 3 equals 0, and x minus 3 equals 0, right? There was kind of an or there, so one of these has to be true, zero product property. Well, here I get x equals 3, and of course over here I would get x equals 3 also, and we would say, okay, well then it's 3 double root. Okay, so we're just remembering back. Just remember back to when we were doing those. Okay, so we're going to take this idea, okay, this is just an idea, we're going to take this idea and we're going to combine it with this next idea. So this is also something that we've done already, and we solve something like this. X squared equals 7. And to solve those, what we said was, well, we're going to take the square root of both sides, right? Raise it to the reciprocal power, now that you guys know all of that. But really what you're doing is you're going to take the square root of both sides. So I'm going to take the square root of x squared, and I'm going to take the square root of 7. Now something happens here that I keep having to tell you not to forget. And what is it? What are we missing? And we've missed this quite a few times. Finally on our test we remembered, but this has a value here of plus or minus, and don't forget that. Okay, I'm going to write you a little note. Don't forget plus minus. Okay, don't forget plus minus. All right, square root of x squared is x. So x equals plus or minus square root 7. So my roots then would be minus square root 7 and a positive square root 7. And those are my roots. Okay, so that's kind of where we're starting. And this is just remembering back. Okay. Well, what we're going to do is we are going to put these two ideas, anyway, together. And we're going to solve equations that have a perfect square trinomial on one side and some kind of number on the other side. So instead of 0, remember we always are trying to get everything equal to 0. Okay. Well, this is a way to solve when you have a number on the other side. Okay, so we're going to put it together. So put together. And here it is. This is what it's going to look like. So, and this is a real basic, super basic one. So I have x minus 3 squared equals 7. Now I'm just putting the two, I'm showing you how to put the two ideas together, and I'm just kind of building until we get to ones that are more difficult and you'll understand the process. So I'm going, you know, teeny tiny step by teeny tiny step here. So putting this together, so this is what I would have, okay, and this is a new problem. This isn't this problem, it's not this problem, it's its own problem, okay? It doesn't have anything to do with this one, nor does it have anything to do with this one. Okay. I'm just showing you perfect square trinomial, I can factor it. If I have something that's squared, I can take the square root of both sides and get plus minus. Okay, so those ideas is what we're taking here. So if I were going to solve this one, then what I would do is I would take the square root of, use some color here, the square root of both sides. Okay, so I'm going to take the square root of both. So I'm taking the square root of x minus 3 squared, and that equals the square root of 7. And I told you, don't forget, over here I have plus minus. Okay, so we're taking the square root of both sides. So our step for this one was now there's going to be more steps in the end. So just for the super simple one, it's take the square root of both sides. Okay, so this one, that's all there is there. Take the square root of both sides. Okay. When I do that, what I get is x minus 3. Remember, if I have the square root of something that's squared, I just get, you know, the base, right? And the base is the whole thing, is the x minus 3. And that equals plus or minus square root 7. To solve this, what I'm going to do is, I'm going to scoot this up just a touch. I'm going to add 3 on both sides. Okay, I end up with x. This, of course, goes to 0. The 3 is not underneath the radical. The 7 is underneath the radical. They are not like terms. They cannot be combined. So the best I can do is 3 plus or minus the square root of 7. Okay, and that's the best I can do. So my answer then, or my roots, are this, are 3 minus square root 7 and 3 plus square root 7. Okay, there's my roots. Oop, and they're out of the picture, and I'm going to move them up. Okay, there you go. There's the roots. Right here. So this is how I'd write it in set marks. Okay. Alright, I'm going to show it to you again. One more time. I have x plus 5 squared equals negative 4. What do you think? Can you do that one yourself? Why don't you stop the video and see if that's something that you can go ahead and solve in the same manner. All right, did you try it? What I'm going to do is I'm going to take the square root of x plus 5, the whole thing squared, right, equals the square root of negative 4. And when I take that square root of negative 4, I'm going to have plus minus. Don't forget that. When I take the square root of something that's squared, I end up with the base, which is the x plus 5. I end up with plus or minus. Remember, if I have a negative under a square root sign, then I have an I situation. So I'm going to pull out its I, and then I would have the square root of 4. Well, the square root of 4 is 2, so I have plus or minus 2I. I'm going to subtract 5 from both sides. Now 5 and I do not go together. They are not like terms, so they cannot be combined. So what I end up with is negative 5 plus or minus 2I. And those are my roots. There's 2 roots there. Here's my set brackets. I have negative 5 minus 2I, and I have negative 5 plus 2I. Okay, so that's putting it together. All right, now that was just the basics of all of this. So I'm going to switch pages on you here. And back to completing the square. This is continued, completing square. I like to put continued, especially for my own notes, because then I know what page went with what. Alright, so completing the square, and this one is continued. Let me straighten up the paper here for you. There we go. So for this, so they don't always look like what we were dealing with before. In fact, that was just one of those baby steps. So they might look something more like this. X squared minus 4x plus 4 equals negative 2. So when I say they're not always going to look like what we had before, the reason that they don't look like what we had before is because they're not factored yet, and you are going to have to factor them. You are going to have to get them to look like this. Okay, so this is your goal so that you can solve it. But what they're going to hand you is stuff that doesn't even look quite like this. This is still one of those small steps. All right, but our goal is to look like, you know, something squared equals a number. So what you want to do is you want to look for perfect square trinomial. So on the left-hand side, look for a perfect square trinomial. Okay, look for a perfect square trinomial, and if you look at this on the left-hand side, you'll see that, oh, this is a perfect square. It's x. This is a perfect square. The square root of that is 2. When I multiply them together and then multiply by 2, do I get the middle term? Yeah, I do. So I know that this sign is just going to follow that this is squared and equals negative 2. Well, now I have something that I know how to handle, right? I know how to solve these. So what I'm going to do then is, now that I've factored, okay, so we look for a perfect square trinomial. That's the first thing we're going to do. And the second thing we're going to do is factor. The third thing we're going to do is solve for x, because now you know how to solve for x. So we're going to solve for x. Okay, so what I'm doing is I'm going to take the square root of both sides equals the square root of -2. I know not to forget my plus minus. When I take the square root of something that's squared, I'm going to end up just with the base, and the base is the whole thing, that x minus 2, because that was what was being squared, right? It's in parentheses. I have a negative sign. I do need to pull out its I, so I have I square root 2. Remember, the I goes in front. The radical signs always go last, so we are really sure what's underneath them. This time I'm going to have to add 2 to both sides. And I get x equals 2 plus or minus I square root 2. So my answer, I should have, because I have a square, I should have 2 roots. So I'm going to have 2 minus I square root 2 and 2 plus I square root 2. Okay, and that's my answer. All right, what do you think? Can you do it? Okay, well, so we're getting there. We're going to do 2 more. One is really going to be completing the square, and I am going to switch papers again because I need more room. So switching papers for me, probably not for you. Give me a second here to switch them out. Okay, so this time we're really completing the square. The other time we didn't have to do anything. It was already complete. It was already a perfect square trinomial. So that's no fun because we don't have to do any work, really. Okay, so we're back on to completing the square, and this time we're really going to complete the square. How much time do I have? 2 minutes. Okay. And we're going to think back to standard form. Okay, standard form. And standard form is a x squared plus b x plus c equals 0. So we're going to need that standard form, so don't forget that. Okay, we already know a lot about that. All right, so let's look at a new one. And this time, we are going to complete the square. Here's my problem. Okay, so this time, so what I said before is look for a perfect square trinomial. So that's number 1. Perfect square trinomial. I'm tired of writing it, so I'm going to abbreviate. But this isn't, right? Because this isn't a perfect square. So I don't have a perfect square trinomial, so I'm going to have to do something about it. So the second thing we're going to do is we're going to look for a perfect square trinomial. If we can't find one, so if yes, then we can factor. So yes, we'll give it 2 ways. Yes, factor. No, move the constant. I'm going to call it C. It's the constant, okay, right here, to the other side. Okay, so we're going to move the constant to the other side. So what I end up with then is x squared plus 6x. That stuff I'm going to keep, and this stuff I'm going to move to the other side. So I subtracted 13 on both sides. Okay, and that's how I moved it to the other side. You don't get to just pick it up and move it. You have to actually do some mathematical calculations, and you already know how to do that. So you're going to subtract 13 from both sides to get it to the other side. Now, I left a big, huge space. Why? Oh, well, because you're going to have to fill it in. You are going to complete the square. We were looking for a perfect square trinomial, like we did in this last one. Looking for this one, it was a perfect square trinomial. I could go ahead and get it into this form. This one isn't. So I'm going to create it. So my step 2 here is I'm going to add b over 2a squared to both sides. All right, b over 2a squared. Perfect. I can do that. So I'm going to have to stop and think. b over 2a, the whole thing squared, which is going to give me, so b is 6. It's over 2. A is 1. And just to ease your mind, we always make a 1, even if we have to change things around. And I'm going to square that, which 6 over 2 is 3. And I'm going to square that. And what I'm going to go ahead and add to both sides then is 9. So I'm adding 9 to this side and 9 to that side. The reason I wanted to do that was because I wanted to complete the square. And this does complete the square. So if you look at this piece now, and I'm going to highlight it here for you. If you look at this right here, I now have a perfect square trinomial. Perfect square trinomial. And I created it. Well, that's what completing the square means. You create this perfect square trinomial by just adding on both sides. This I can factor. What I'm going to have then is x. I have a 3. I know when I multiply them together, I get the middle term, and multiply them together and then multiply by 2, I get the middle term. And then this sign here is what goes in here. So I have plus this whole thing squared. Negative 13 plus 9 is going to give me a negative 4. And now I'm back to something that you know how to solve, right? It looks like that stuff I showed you in the very beginning. So what you're going to have then is you're going to do square root x plus 3 squared equals square root negative 4. Now, again, I've said it, I don't know, 5 times now. Don't forget your plus minus. That's a big deal. That's where you get your 2 roots, for the most part, unless you end up with a 0 there. I'm going to end up with x plus 3 equals plus or minus 2i. I had to pull out its I. It's a negative and a radical sign. That gives me my I. I'm going to subtract by 3 on both sides. I have x then equals negative 3 plus or minus 2i. And then in my, I'm going to move this up, in my set brackets, then I have negative 3 minus 2i, negative 3 plus 2i. Okay, and that's called completing the square. We completed the square by adding something on both sides that was going to help us complete it. So by adding that 9, we completed the square. And in the end, we ended up with our 2 roots. And we expect 2 roots because I have a squared term. Okay, completing the square. Now, this, let's go ahead and add the rest of these steps in. So the third step would be to factor. And the fourth step would be to solve. Okay. Now this example is a equals 1, so I ran out of room to write it there, but I'm just going to tell you right now, and you can highlight this example, a equals 1, and then my next example, of course, is going to be a doesn't equal 1, and I'll talk you through that, and then we'll be done, and I'll show you some of the more difficult ones in class. Okay, so again, yes, I have to switch pages. It takes me a lot of pages to write this big for you on these because you told me that this is what you like better. So this is the last one for this. Completing the square. All right, and so these steps are always the same. It just depends on what kind of problem you have. So this is an example. Where a equals a number other than one. Alright, example where a equals something other than 1. So this is what you're going to get here. So when you do these, all you have to do is this. Well, all you have to do, trust me, I'm picking the easier ones. 5n squared plus 100 equals 30n. Okay, so you might get something that looks like this. The first problem with this is that a equals 5. Well, a equals 5. So what you want to do is you want to divide each term by a. So number 1, divide each term by a. Okay, so we're going to divide each term by a. So I'm going to divide that by 5, that by 5, that by 5. Once I do that, I end up with n squared plus 20 equals 6n. Okay, well, I'm looking for a perfect square trinomial, but I can see there isn't one. And I have an n on this side and n on that side, and that's not any good for me. So I'm going to go ahead and subtract 6n from both sides. So I have n squared minus 6n. And I can tell that 20 is not a perfect square, so I'm going to go ahead and get rid of it and move it to the other side by subtracting 20 on both sides. From here, what I'm going to do is I'm going to add, so I'm just back up into my other terms, or my other, what do you call these, steps. So I have b over 2a squared, but I'm using this equation now. Forget this thing, right? I simplified it. I'm going to use this one where a is not a number. So then what I would have is negative 6. Sometimes I don't worry about the sign because I know I'm going to square it, so I may have done that in my other problems, don't really know. But the reason that you might want to know is because you really might want to actually use that sign. Maybe mine were all positive, don't know. Anyway, is because when you're factoring, that this is what you're actually going to end up with when you're factoring, and when you're doing fractions, it makes a difference, and I'll show you that. Alright, so I'm going to end up with 9, adding 9 on both sides. They're not always adding 9 to both sides, just so happened that the 2 I did added 9 to both sides. Alright, and then, so now what I have is I have this perfect square trinomial, and I know I have a perfect square trinomial because I created it. I'm going to go ahead and factor that. So when I factor it, I have n 3, right? It's minus squared equals negative 11. I'm going to take the square root of both sides. And I know that I cannot forget my plus or minus because that's part of the problem, and that's actually gives you, that's where you generate your two roots from. Take the square root of something that's squared, I'm going to get the base, and n minus 3 is the base. I have a negative under the radical sign. I know I'm going to have to pull out its I. I'm going to add 3 to both sides. these are not like terms, nothing I can do there, but just set them up like this. So 3 plus or minus I square root 11. And then I can put these in my set marks. So I have 3 minus I square root 11, 3 plus I square root 11. Alright, so that's completing the square. Right here in your steps, divide each term by A, and then number 2 would be just follow steps. No, that should be a 4 and I wrote far. A equals 1, okay, which is what we had done on the previous page. So completing the square. And we'll talk about some fractions in class, because those, my friends, are always much trickier. All right, good luck.